Hi everyone, welcome back to my channel and please subscribe to my channel so that it gives me motivated to do much more videos. And I will be starting with GFG portal. Today, problem of the day is circle of strings. If I go to my strike, it was 386. Okay, and here, the problem is difficulty category of hard, and it was asked in so many interviews in so many companies like Flipkart and Accolite and Microsoft and FactSet. These are the companies this question was asked. It was, I would say, it was medium level question, not a hard. I can give you a more overview and glass through the when we are discussing through the problem itself. Okay, let's go to the problem. Given an array ARR of a lowercase string which contains all lowercase and determines if the string can be chained together to form a circle. We have to form a circle. We'll see how what was the conditions they have given. A, for example, a string X can be chained together with another string of Y if the last character of X is the same as the first character of Y, which means that there is kind of a chaining mechanism where we are linking the this is an suppose this is an X string which contains the last character of C that should be mapped to the Y string of the first character, which means for example C should be mapped to the C here. So this can be formed as CC. Here the linking the last character of the first string should map to the second character of the first letter and so on and so forth so that even we get even if we have even every string of an array can be chained with an exactly two strings of an array, one with the first character and second one with the last character of the string. It will form a circle, which means that last character should be again mapped to the first character. So here in this case the C should be mapped to the third string, the first character. So this is the second occurrence. And F, there is no first letter of F. There is a no word starting with F. So we can't form a circle in this. So we can simply return zero. If we can able to do the circling chaining mechanisms, so we can able to return one. For example, if we see this example two, B should map to B, the first character, and C should map to C of the first character. D should map to D, and also we should make sure that the last character should map to the first string first character. So A should. So it's complete cycle. So this can be form a circle. This is an expected time complexity. This is an auxiliary time space. So yeah, and length of string is 20, which means we have 20 strings inside that. So it's not an hard level, but it was considered hard. It's pretty easy and medium level question. Because why kept as hard? Because of the it was completely, if you observe, there is a mapping between one character to the another character, and it's kind of an, if we observe carefully, first strings are considered to be an adjacent, and in the adjacent we have the first point representing the starting point, source point, and the last character representing the destination point. For example, this is an edge starting from A and going towards B. Similarly, this is an another edge which starting point as B and ending towards C. If we consider in that approach every string as an edge and starting and destination, then we can able to form one graph, adjacent graph, where uh, every every occurrences and mappings we can form an adjacency list, and then we can do the in degrees of every characters and also out degree of every character. Here B is an out degree, right? It goes to the another B, and here B will be the in degree, so that we can calculate both the in degree, out degree, so that the circle here at the ultimately we have to form a circle. So in order to do the circle circle mechanism, where every occurrences of individual character should map to the every occurrences of uh, other character, which means that in degree of each character should be equal to the how degree of each characters. So if we can able to do that, then we can able to form a circle, no doubt in that, and we can simply return whatever whatever it might be. So that is the case, and let's go to the solution here. Let me explain one more example to get more understanding. Here the given array A, B, C, and GF. Let me take one highlighter, draw, oh, pen, highlighter. Yep, plus here given array, and ABC is the first string. You can see ABC, and C is mapping to E. Here the given an array of strings, and we have ABC. If you see, C is mapping to the first character of C, and E should be mapped to the first occurrence of E, and G should map to the first occurrence of G. I should map to the first occurrence, and A should map to the first occurrence of another string. So this is a circular form where you can see A is mapping to C, C is mapping to E, E is mapping to G, G is I to A. So this is a circular formation of given string. And and here if you see all, and also we should make sure that all should be an single component, strongly connected component, so that we can able to form a given array into a circular representation in a single strongly connected single component. If you have two components which are not connected to each other, then it is very difficult and we can't able to form a circle. And here you can see it is a circle. So that is how we can able to solve. The institution is the key insights is nothing but you have to model the problem into a graph problem, and you have to think every string representing as an edge, and the first character of the string is an source node, and the last character of the is known as destination. Here the string edge, the first and source and destination. We have to think about it, and solution requires in degree and out degree of every node and every character, and strongly connected component connectivity of a graph to ensure all strings can be chained circularly, which means that we can able to do the circular rotation. So approach is that we have to build a graph. Either you can use in Java, you can use map, which is the first will be the character, the entity, and second one will be the list, adjacency list, to store a number of the particular node has a number of occurrences, number of points stops there. For storing adjacent list in a graph, and keep track of in degree and out degree in an array, and we have to able to build a graph which consists of lowercase up to A to Z. That's also straightforward. And Eulerian circuit conditions, which means that you have to form a circle, right? This is the where problem identification comes in. Eulerian circular condition states that in every in degree of number of edges coming into the node should be equal to the out degree of edge going from the node. Both should be unequal in degree and out degree must be equal for every node involved, so that it will satisfy the circuit conditions, which can able to form a circular patterns. Graph connectivity. This is another principle. Graph connectivity which does strongly connected components that can be performed using DFS, DFS also, which like all the nodes are part of one single connected graph. And coming to the solution is pretty straightforward. This is the method which is given is circle or not, and we have to create a graph which is an existentialist here graph, which takes the first is the character, and second one will be the list of characters. And I have taken the in degree array or degree array, which consists of 26. This is an arbitrary constant which can be ignored constant, and visited to store whether all the units are visited. I will come to on. And first of all, we are building an we are building a graph here. Basically, it was simply iterating through the string and taking the first character and the last character and making a connection in the graph. You can see compute if absent, which this is a method where if the character is not present, it will initialize the array list. In Python, you can use default dict, and in C++, you can able to use there is no null references, null pointer exceptions in C++. You can able to add and remove. So yeah, in Java you have to use this null check methods, which will internally does by checking whether character is not present, it will initialize the object value and then adding the and character for the starting string as a key, and this is the value. And here in degree and out degree we are incrementing, so that in degree pointing to the this is starting node, this is an ending node. When we are going towards from here to here, which means an out degree for this. So starting will be the out degree and ending will be the receiving, which is then in degree. We have to increment the counter, and after that we have to check whether both in degree and out degree are equal. If it is not equal, which means that there is an inconsistency of it doesn't follow the Eulerian circuit condition, we can simply return zero, which is not eligible for circular patterns. And then we have to use the strongly connected components like using traversal technique, DFS, traverse from the starting node using this graph. It will go to the DFS method. Here DFS method is straightforward. A visited array, I take a visited array because of to store, you should not go again and again. DFS is nothing but if you go from one node to another node, again if the bad tracking comes in, again we will encounter same node again and again. In order to avoid that, we can use pruning technique here itself, checking the whether it is already been visited. Please do not go for the further iterations. And if it's not visited, store in visited and go for its children. And in this children, we are doing a DVFS again to connect all the connected component in a single component. And when we are storing that, we are storing right after that visited having, we are storing as one. You can see. So the sum should be mapped equivalent to the size, as we are storing one only. So sum will be the number of elements present inside the visited of the particular strongly connected component, number of vertices, and graph will be representing the initially we created a graph, right? Initial original path and computed path. If number of elements are both are matching, the initial created adjacent list and traversal after a strongly connected component. If both are not equal, which means can't able to which doesn't follow the second criteria, which is nothing but strongly connected components are not which contains two or more than one in connected component, we can't form a circuit pattern. So this is second condition failing, so we can return zero. First condition, Eulerian circuit condition. Second condition is strongly connected component. It should contain single connected, and then we can able to form a circle. That's all, and it will return. If I can compare this, I got AC here. You can see AC. If I view this code, the same code I wrote. DFS strongly connected arrays equal. This is a stream method which can able to do some in a single line. Yeah, that's all. Thank you. Please like, share, and subscribe to my channel.